Roots of the Science podcast with your girl, Anne with an E.
Hello, everyone, and welcome back to another episode of the Roots of the Science podcast with your girl, Anne with an E. If you are new here, welcome to the show. Remember to tune in on all the social media platforms so that you're well informed of when new shows come out, and also you can listen to us wherever you love to listen to your podcast. Make sure that you rate the show as well as click on the notification button so you know when a new episode is live, like that. So during this month, we've had a focus on guests regarding the COP28 summit that was happening in Dubai in this month of November, as well as early December. And we're continuing with that theme for this week's episode. So because of the escalating climate change challenges, the agriculture sector is undergoing great transformation, seeking sustainable practices to ensure food security. On the 2nd of December 2023, at COP23, Michael Kremer, the 2019 Economics Nobel laureate, joined Her Excellency Mariam Al-Maheri, the UAE's Minister of Climate Change and Environment, as well as the COP28 Food Systems lead, with Bill Gates, the co-chair of the Bill and Melinda Gates Foundation, to announce the creation of Aim for Scale, which is a new mechanism to support food systems innovation that improves resilience and mitigates emissions, as well as the transition of them to scale. One promising innovation announced during this event is the utilization of microbial fertilizers. Unlike traditional synthetic alternatives, these fertilizers harness the power of beneficial bacteria to enhance nutrient absorption by crops, thereby improving yields as well as reducing the environmental impact associated with the conventional fertilizer methods. On today's show, I have the honor of speaking to Prof Tavneet Suri. Prof Suri is a renowned researcher at MIT Sloan School of Management. Her work sits at the intersection of innovative solutions for agriculture, climate change, and global development. Originally from Kenya, Prof Suri brings a unique perspective on agriculture innovation, with a particular focus on transformative potential of microbial fertilizers in low and middle income countries such as Kenya. Let's tune in to hear about all of this and, of course, so much more. Let's go. Hi, Prof Suri. Welcome to the show.
Hi, Anne. Thanks for having me. It's a pleasure to be here.
It is such a pleasure to have you onto the show, and I'm just going to get straight into it. Prof Suri, you grew up in Kenya, and I'd like to know how the influence possibly of growing up in Kenya actually got you into this field and having an interest in innovations in agriculture, and more specifically on what you're working on now, microbial fertilizers.
Great. Thanks, Anne. Well, I guess I went to college and majored in economics and then decided to go do a PhD in economics. And I always knew I wanted to do something related to back home in some way. And so, as I was doing my PhD, I took a class on, development economics in Africa and realized that's what I wanted to do. And I knew I would, try and do research that had applicability back home in some way. And so my thesis was on the use of hybrid maize in Kenya. I got to work with some local organizations on the ground and fieldwork. My first fieldwork experience was with this organization called Tegemeo Institute that does agricultural research and policy in Kenya. And then, the rest is kind of history. And, once you start to do that, I liked, and I still do like having a foot on the ground in Nairobi, or in Kenya, not necessarily Nairobi. So life kind of stayed that way. I still run a pretty big research program in Kenya, in a couple of other African countries that I work in. I'm there, 3 or 4 times a year, which is nice, especially during the winter in the US. A January trip home is pretty nice.
I can imagine. Lovely. It's good to know sort of the context of how it all started. So with that background in mind, so COP28 just completed, I think it was last week, and a lot of announcements were made. One of these was the Aim for Scale program on food security, specifically focusing on food security. So I'd like to hear your input on the implication of this announcement, specifically on innovative approaches such as microbial fertilizers by smallholder farmers.
Yeah, it's a great question. I mean, I think the announcements are fine. The question is whether there's funding to kind of really get somewhere with these things, right? One of the things with agriculture is just the levels of R&D and the expenditure on the kind of what we would call R&D side are just very low, at least in sub-Saharan Africa, right? We're not really creating technologies that can not just sort of help environmental stuff, but also improve yields so that we deal with food security at the same time, right? If you think of the last couple of years, the hunger rates in parts of Africa have gone up dramatically because of climate events, all sorts of events, right, happening, droughts, etc. And so I think we want to think about things that will both kind of improve productivity, but also reduce the carbon footprint. And there's, not many of those, and they need to be thought about carefully and tailored to the context. That's both the kind of beauty, but also the complexity of agriculture, right? What works in even one part of Kenya won't work in another part of Kenya because the soils are different and the temperature is different and the rainfall is different and everything else is different, and the costs are different because the infrastructure is different. So it's not just kind of natural conditions being different, but the economic conditions are different, which has implications for prices and costs for small scale farmers, right? So in a world that looks like that, with lots of heterogeneity and both the benefits of technology and the costs of technology, we really have to test these technologies before we start to think about smallholder farmers using them, right? They're not going to use things that are not profitable for them. And I think often we don't think of how to really, test technologies and adapt them to be profitable for the small scale farmers. So I think it's great that there's a focus on food security. It's urgent. If you look at numbers for the last year, it's more than urgent. But we also need to be able to say we have money to run kind of modern R&D type programs where we're testing these technologies. We're testing whether they're beneficial for farmers and not just, on 5 research sites in, that are research stations of the government, but also at the local level in communities across the continent. And that takes energy, effort, and some funding, right?
Of course. I love that you are touching on funding because obviously, like you said, everything needs the funds before we can see the full implementation. And you spoke on the idea that the funds are needed in order for us to see if these will work. So how, in terms of this research and the development side, where is it in terms of testing, for example? Where are you in terms of this type of research? How far into it are you?
Yeah, good question. I mean, let me say 2 things. One is, the microbial fertilizers are actually being used in the US. They've scaled pretty well with at least one company, and I'm sure many will follow suit when they realize this is happening, right? This for sure will happen, but there's farmers using them in a large part of the US already. And the same is, and so they've been tested and tried and tailored for the US. I think the same is true in some parts of Latin America, but I don't work in those parts of the world, so I'm going to talk a bit about the part of the world I work in, which is sub-Saharan Africa. There's very little microbial fertilizer. So, these are sort of supposed to be, we call them fertilizer, but they're not really chemical fertilizers, right? It's basically microbes that are going to try and fix nitrogen in the soil, which means sort of pull nitrogen out of the atmosphere and use it for the plant. And the idea is you would replace synthetic chemical fertilizers, which are a huge cost on the environment, right? All the nitrogen fertilizer in the world right now is, something close to 2% of emissions. that's a lot for one thing, right? So, the idea is these would replace all of that fertilizer, but in Africa, they would also be a cheap source of nitrogen for farmers who don't use fertilizer, right? There's a lot of farmers who just can't afford fertilizer because all the fertilizer is mostly imported. There's very few plants across the continent that produce it. And so it's a way to also discourage future emissions if we think that we need to raise yields and productivity in Africa, right? So in Africa, there's very little happening with microbials, really. There's some on legumes, but not for cereal crops, right? And so I can tell you a bit about what we're doing. We worked with the Kenyan government to test, we mean not just me, actually, our partner who's building the microbial fertilizer. So that was them, not me. But they tested with the government on research stations whether the microbial fertilizer would even work in Kenya, right? I mean, just because it's working in Kansas doesn't mean it works in Kenya, right? And then they got approval to distribute it because those trials went fine. But the problem with just going straight to distribution is it got tested on a bunch of research stations, which were pretty, well controlled, well managed. There's water, there's irrigation, that's not what smallholder farms look like, right? And so we're now working with them to try and build a test across a bunch of smallholder farmers in the country, right? And in different parts of the country, so you get a sense of, does it work in this place but not in another place? Or does it work really well here but not so well here? So we need to tailor it. And then understand if we do need to tailor it, why is it not working? What do we need to change about it that will make it work, right? So this kind of testing, adapting, testing needs to happen. And so we're going to hopefully do that in the coming year in Kenya. And, the first one of these is going to be proof of concept, Anne, and proof of concept of a way to test and adapt these microbial fertilizers. The nice thing is they are easily adaptable, more so than things like, nitrogen-based or whatever. And I'm hoping they'll also be a lot less costly than fertilizer because they're just microbes and they don't need a lot of space to travel, it turns out, right? If you think of synthetic fertilizer, I've got bags and bags that I need, right? And microbes turn out to be, the other spectrum of size. They're microbes, they're tiny. So, it has to be that the costs, distribution costs, and therefore costs to the farmer are just going to go down a lot, right? So, and, that leaves us with the testing being even more important. If we think the costs are going to be really low, we want to make sure it actually has benefits, right? On yields. So that's kind of where we are. It's really early days, but I think if we can build, both a way to test with farmers and a way to adapt in Kenya, then it's going to be easier to go to another country and another country, right? So I'm hoping that, in a year or so, we'll have learned, so much that we can take those learnings to another context.
Interesting. That's so fascinating. So there need to be more on-site experimentation and testing being done. That's
Correct.
basically what you're being said. I'd like to know for somebody who's listening and is like, okay, Anne, I know what fertilizers, like you said, when you think of fertilizers, we think of the bags, the 50 kg bags of fertilizers, etc. So for someone who does not have an understanding of what microbes are, could you maybe paint the picture of what exactly these microbial fertilizers maybe potentially look like? And then when it gets in the soil, what do they do? I think just so that people really understand why this is a better alternative, apart from the environmental effects, benefits, but like, how will this actually work practically, or rather, how does it work practically?
Yeah, that's a great question, Anne. I'm not sure I can answer all of that just yet, and I'll give you bits and pieces of why.
Sure. Okay.
So the microbes are tiny, right? They're bacteria. Think of bacteria level size things, right? And the way, at least the way our partner who we're working with, who produces these, does it, they kind of produce these bacteria and then freeze dry them. And then you get these little tiny freeze dried packets, and then you add water to them to sort of waken up the bacteria again. And then you just coat the seeds in it before you plant them. So this is all maize at the moment. And so you coat the maize seed and then you plant them as you would.
Wow.
So that's kind of how it works at the moment, you know. So it is also a different way of applying fertilizer, right? That's not what we do. We don't have some,
Yeah.
it's like
Yeah.
a tube of freeze-dried stuff, tiny small tube,
Okay.
right? Like, so we do have to also see how farmers respond to that. There's also the
Mm.
behavioral piece, right? Of, they'll be like, what is this thing, right?
Yeah.
And then what's nice about these is when you coat the seed, the bacteria just cling to the root
Oh.
as the plant grows, and then they pull in nitrogen straight to the roots. So I think that's kind of the basic 101 of how it's working. Now, the one thing that we also have to think about carefully as we do the testing on these is, for example, in the US, when they send them to farmers, most of our trucks are pretty refrigerated. We have refrigerated vehicles. We have all this stuff, right? That's not true in Kenya, right?
Yeah.
So one of the things we need to also work on is test if the bacteria, kind of stay stable if we
Mm.
transport them to the middle of nowhere in Kenya,
Mm.
right? And so we have tests for that. So this is part of the research program, is understanding, it's not just so easy to take a technology from the US and dump it in Kenya and say, oh yeah, we got approval because the tests
Yeah.
look good, where we controlled the tests. Like, no, we need to be able to produce a system that's truly scalable
Mm.
in the context that exists on the ground, right? In the context of how it's going to be distributed in Kenya, in the context of how we think farmers will respond, in the context of how they'll use it.
Yeah.
And those are things that are still open questions, right? And so we're hoping to test some of that in the research that's happening next year.
Mm-hmm.
And collect a lot of data that tells us kind of how all of the bacteria performs, how the crops do, how farmers respond to this. And then we'll have we'll have a much better sense of what the scalable business model looks like,
Mm.
right?
Mm.
Yeah.
Interesting. That's so interesting. I was going to touch on some of the challenges, and you've touched on it, the perception side of, how will the farmers respond to this? And also now you spoke on the logistics. So are there other potential challenges that you are potentially seeing that you are going to maybe look at more as you test this fertilizers more on site across the various different locations next year?
Yeah, I think those are two big ones. The other one is, they might work well somewhere and they might not work somewhere else. And then we have to think about, understanding why they're not working somewhere else. And how do you adapt them? Do we need to add some local bacteria to the microbial fertilizers to make them more productive? So there's a bit of a science question there too,
Mm.
depending on what we find. That's why, it's kind of hard to say, like, where are we going to be in a year? Because it
Yeah.
just depends on what we find, which is the beauty of research and science, but also, the challenge of research and science. Because we'd love to say, oh, we'll have something ready in a year that you can just send everywhere, right?
Mm.
And that's not how this works. So I think that's going to be the other challenge, is kind of, building a productive program of understanding all of this, right? And tailoring the technology so that it does work as well as it possibly could for small scale farmers.
Yeah. So the lot of unanswered questions are
Yes.
many, but I think, like you said, it makes it exciting because it means that there's
Yeah,
work to be done.
absolutely.
And I think
And the other bit that's super exciting, honestly, Anne, is, not that many farmers use fertilizer. If they do in Africa, it's so low relative to what people would recommend to get good yields, right? That's why yields are lagging in the continent. That's why fertilizer use is lagging. And it's because it's really expensive, right? It's really, really expensive by the time it gets to the farm gate. So what's exciting here to me is just we have an opportunity to remedy that.
Yeah.
And we have an opportunity to possibly remedy that. Let me say possibly, because we don't know yet.
Yeah.
But we have this huge opportunity where if it worked, we would be able to change the entire landscape of food security and yields of food pretty dramatically, right? Because the costs will be much lower, yields would go up, and not only would the costs to the farmer of the actual microbial fertilizer be low, but we wouldn't have the carbon cost on
Yeah.
everybody else, right? And that's, you're kind of in between a rock and a hard place in sub-Saharan Africa, because even if you do, imagine every government said we're going to give fertilizer to every farmer for free, right? The cost on the environment is enormous of doing that.
For sure.
Right? Imagine producing enough nitrogen fertilizer to put fertilizer in the right rates across all of sub-Saharan Africa. I mean, the carbon footprint of that will be enormous. And so what's exciting here is we might have a way to do that without, imposing this huge other cost on everybody else.
Yeah, this is a potential solution to enhance food security as well as, mitigate all these climate effects, which is definitely exciting. Prof, as we are sort of wrapping up this discussion, which is really interesting, with your expertise, I'd like us to touch on the policy side. How does the policy and maybe collaborations, how could they work together? I'm going to be optimistic here because I think this is really exciting to accelerate this when it works in terms of like adoption.
Yeah, it's a great question, Anne. I think there's a couple pieces here. We've been working closely with policymakers and people on the ground, partly because, when you try to invest in technologies like this, you have to test them properly first, right? You need to make sure they're not doing anything bad, right? So you do have collaborations on the ground. I think on the policy side, it's really, to me, an open question depending on how farmers react to this, right? Ultimately, we're going to want them to use it, and they're going to be the ones who have to use it. If they do like it and the costs are still high, then there's maybe a role for policy there. There's maybe a role for policy, and when you scale up, how to kind of teach farmers how to use it, because it is quite different from regular fertilizer, right? It's not a what do they call them? A granular fertilizer, right? Like everything else. And so, there's a role there. There's a role for policy to try and engage with farmers on how to use new things. I think the other piece is to sort of encourage more testing of things like this. It doesn't have to be microbial fertilizer, but in general, can they build more collaborations where they're testing technologies that could be good for food security and climate change? There's people thinking of technologies where, they build seeds that are flood resistant and seeds that are drought resistant and all these things that sort of will help farmers a lot because they're going to protect them against both droughts and floods, but also climate change that's going to make these things more frequent, right? And so I think there's also a role for policy in saying, look, this stuff is coming, right? All of climate change is coming, and we need to do the experimentation now. We can't wait for 10 or 20 years to do that. And so I think, policy can start to already shift in that direction, saying, can we reach out to people working on these various things? Can we provide them the avenue to come test in our economies in a way that makes it simple, straightforward, encourages the testing so we know what we have to fight what's coming, right?
No, fascinating. And you are absolutely right that I think we need to start thinking in advance. And it's true. There are a lot of people who are doing a lot of amazing research. And I hope it can be beneficial to the people on the ground who definitely need these innovative solutions. And I am so excited about the work that you and your partners are doing, because this sounds super, super exciting. And I hope as you continue testing, you get to the results that are needed for proper implementation of this very innovative solution.
Great. Thanks, Anne.
Thank you so much, Prof. It's been so lovely.
Anytime. Thanks for having me on your show.
Sure. And everybody else, thank you so much for tuning into another episode of the Root of the Science podcast with your girl, Anne with an E. Until next time, goodbye.